Aw, I love the Grinch. I love that story. So right here you can see a little gif of his heart growing. His heart was dilating. Our lesson today is on dilations. And typically when you hear the word dilate, like they dilate your eyes, they dilate your pupils at the eye doctor and you can't see very well, that means they make them bigger so they can see in your eye a little bit better. The Grinch's heart dilated, which means it got bigger. But sometimes in math, when you hear about dilations, we're talking about either enlargements or reductions. So let me show you. So these circles, for example, if I start both of them at the origin, one of them is bigger than the other one. This big circle would be a dilation of the smaller circle. So let's say this is your pre-image and this is your image, just like what we were doing with the translations. Translations, you're just sliding things. Dilations, you're making them bigger or smaller. So you either have an enlargement or a reduction. Let me see if I can do another figure over here. So here's a little small square, and then maybe I decide to make that even bigger like that. So these two squares, one of them is a dilation of the other one. We could say that the smaller one is the pre-image and the larger one is the image. So this is what we're going to be talking about today, and I think this is pretty easy. It's similar to translations in that it's really straightforward, the rules and everything, so it's pretty easy to learn. Let's go ahead and get started on your notes. You should have the front and back of your notes for this lesson, so we'll go ahead and get started with that. So the name of this lesson is Dilations. If you're in my class and you want the day, it's 1.2.2, first grading period, second week, second lesson, or second day, Tuesday. So I went ahead and put in the definition of dilation. Now, the technical definition of dilation is to make something bigger. So I didn't include making something smaller. I don't want you to see the word dilate and think, oh, that could mean make smaller, because it really doesn't in everyday life. In math, we talk about dilations and we talk about making something bigger or smaller. But the technical term is to keep the same shape, but to make it bigger. Scale factor is what we look at when we determine how much bigger or how much smaller we've made a shape. So remember, it said that the Grinch's heart grew 3 sizes. So that means that the scale factor for his heart was 3. So that was the scale factor for his heart. If it had shrunk, if it had gotten smaller by 3 sizes, then the scale factor would have been 1/3 instead of 3. So it's 3, meaning that it got bigger. If it had been 1/3, then that means it would have shrunk to 1/3 of its original size. So scale factor is, again, how much bigger or smaller. But I want to also make a note that if the scale, and we'll just say SF for scale factor, if it's bigger than 1, if it is greater than 1, then that means the figure will be enlarged. If the scale factor is between 0 and 1, and typically that means if you see a fraction, but not always, because sometimes it could be an improper fraction, so I don't want you to get caught up in that. But if it's between 0 and 1, that means the figure is going to be reduced, or it's going to be what we call a reduction. So reduce means make smaller, enlarge means make bigger. And the scale factor is always in terms of multiplication. And I'll talk to you about that a little bit more in detail on the next couple slides. I also want to mention that on all of the problems we're going to do today, the center of the dilation is the origin, 0, 0. There are other types of dilations that the center of dilation is another ordered pair, but all the ones we're doing today are 0, 0. So on this particular problem, it's saying here's our figure here, our pre-image, and we'll go ahead and label that. The scale factor is 2. What that means is that we are going to multiply times 2. We're going to make this thing 2 times the size it is. And all you have to do on that to get your image is to multiply each of these numbers by the same number. Multiply each of these numbers times 2, and then that will get you your ordered pairs for the larger image here. So we know that because we're multiplying times 2 that the image is going to be enlarged. It's going to be larger than it is. So if we multiply every single one of these numbers by 2, we will get the ordered pair. So 0 times 2, 2 times 2 is 4, 2 times 2 is 4, negative 1 times 2 is negative 2, negative 1 times 2, negative 2, and negative 2 times 2, negative 4. So this is what my new image will look like, the red one. And if you remember yesterday from your video with Miss Laney, the new points are called A prime, which is just a little marker, a little tick mark, B prime, and C prime. So A is 0, 2, A prime is 0, 4 because we multiplied everything times 2. So scale factor is 2, which means we multiply times 2. And I forgot to just state, if this is called the pre-image, this is called the image. So like before and after. Okay, so let's take a few notes. An enlargement makes a figure larger. The scale factor for an enlargement is greater than 0, or excuse me, K is greater than 1. And that means that it is greater than 1. So K is greater than 1 means it's greater than 1. A reduction makes a figure smaller. So the scale factor for a reduction looks like this. 0 is less than, K is less than 1. So it can't be equal to 1 or equal to 0. It's got to be between 0 and 1. Usually that means that it's a fraction. So it's between 0 and 1, such as the number 1/4, for example. So I have a trick for you that you can use to find out whether it's between 0 and 1 or whether it's greater than 1 if it's a fraction. So let me just give you an example. What if you had the fraction 7/5? Well, 7/5 is a fraction, but it's an improper fraction. So one way you can do it is if the numerator is bigger than the denominator, then this number is greater than 1. So this is greater than 1, so that means it would be an enlargement. If you have a fraction like 3/4, the numerator is smaller than the denominator, so K is between 0 and 1 here, and this would be a reduction. Another way you can do it is, let's say you have something like 5/4. Put in your calculator, 5 divided by 4. Well, that equals 1.25. 1.25 is greater than 0. If you have something like, well, your 3/4, put in your calculator, 3 divided by 4. Well, you'll get 0.75 or just 7.75. Well, if this number is not greater than 0, if this is not a 1, 2, 3, 4, whatever, then this is less than 1, is between 0 and 1. So that means this is a reduction. This is an enlargement. So even though you have a fraction, I don't want you to look for fractions and think, oh, that's a reduction, because that's not how it works. It is a number that is greater than 1 or it's between 0 and 1. So this is a couple different ways that you can kind of double check yourself when you're trying to figure out whether it's an enlargement or a reduction. So let's practice what we just talked about. Example 2 says K equals 1/2. So 1/2 is a fraction. It is also less than 1 because if I put this in my calculator, I would get 0.5, and that doesn't have a 1 here. It is less than 1, so this would be a reduction. K equals 6. 6 is greater than 1. We know that, so that is an enlargement. 3/4, if you're not sure, put in your calculator. 3 divided by 4, you will get 0.75. That is not greater than 1. It is between 0 and 1. So this is a reduction. This was the one that I gave you a while ago. 5 divided by 4 equals 1.25. 1.25 is greater than 1 because it's got this 1 right here. So that would be an enlargement. So example 6 wants us to graph this dilation. The center of the dilation is 0, 0. The scale factor is 1/4. So it's always multiplication. Multiplying times 1/4 is the same as dividing by 4, because you know those reciprocals, dividing by 4 is the same as multiplying times 1/4, and these are opposite of each other, and these are reciprocals of each other. So we just need to divide each of these numbers by 4, and then we can just graph both of them over here. So 4 divided by 4, let me change colors here. 4 divided by 4, easy. 1, 8 divided by 4, 2. This one's a little bit harder. We can write 5/4 and 7/4. We can change them to decimals just so we can see where they're going to be on the graph. And then -8 divided by 4 and 1 divided by 4 is going to be 1/4. So this is my A prime, my B prime, and my C prime here. All right, so 5/4 is the same as 1.25, and 7/4 is the same as 1.75, so we can kind of figure out where those are. I'm going to graph the red one, and then I'll come back. So I actually just mismarked one of these. This should have been a -5 instead of a +5. So -5/4, -1.25. So let's do the blue one. 1, 2 is our first point. That's our A prime. B prime is going to be -1.25, which is somewhere about right there. And then 1.75, which is almost to the 2 line. And then the last one is -2 1/4. -2 1/4. This is much, much smaller than the original. But there we go. All right, so this was a scale factor of 1/4, which means that the red triangle was reduced to 1/4 of its size. So example 7 is asking us to determine the scale factor of the dilation. So to determine the scale factor, we actually only need to do 1 point. So I'm just going to do the A and the A prime. So let's see, if A is, what is that, 9, 9. And A prime is 3, 3. Well, what I just need to do is determine, okay, to get from the A to the A prime, what would I have to do? So how do I get from 9 to 3? Well, I would divide by 3. I know it is a reduction because this triangle is a lot smaller than this big one. And so if it's a reduction and I'm dividing by 3, I need to put this in terms of multiplication. So divide by 3 is the same as multiply times 1/3. So the scale factor is 1/3. You can also do another point just to double check yourself and make sure that if you divide the other ones by 3 that you get the same thing, because you should get the same thing for no matter whether you use A, B, or C. So you have 2 problems for practice. One of them says dilate the figure using a scale factor of 1/4. So divide everything by 4. This means divide by 4. And the other one gives you 2 figures and it asks you for the scale factor. Remember that you only need 1 point to do that. I want you to try these on your own and be ready to discuss them during class. Tomorrow we will go over these during class, during our live lesson.